a Blue Coat scientist at Science North. Today I have a fun science demonstration to show you on the topic of rocks and minerals. We will be looking at 3 different types of rocks and how they are formed: igneous, sedimentary, and metamorphic. But before we do this, let's review the difference between a rock and a mineral. Let's start with minerals. They occur naturally in nature. They are inorganic, so that means that they're not made by organisms. They're not liquid or gas, so they're solid. They have a definite chemical composition, and they have an internal structure, which means that the atoms are arranged in a systematic pattern. Rocks, on the other hand, well, they also occur naturally in nature, but they are made up of 2 or more minerals. There are 3 main groups to rocks: igneous, sedimentary, and metamorphic. So let's take a look at a baking format. So you are a chef and you want to bake a cake. In order to do this, you need to find the ingredients, such as flour, sugar, and eggs. Now everything is mixed all together and then baked. And then once it's done, you get a cake. Well, let's bring this back to rocks and minerals. The minerals will represent the ingredients, while the rock itself is represented by the cake. So you need to add all other factors to the minerals, like erosion, pressure, and heat. Well, then you would obtain a rock. So for example, if you would mix quartz, feldspar, and mica, your end would be granite. As we mentioned, there are 3 different types of rocks: igneous, sedimentary, and metamorphic. Altogether, they form the rock cycle. Now, the rock cycle allows us to understand the types of physical and chemical changes that can occur that will result in formations of new rocks. Let's start by taking a closer look at igneous rocks. These rocks are formed by molten material like magma and lava, and it becomes solid. Now, this can happen 2 different ways: intrusive and extrusive. For intrusive igneous rocks, it means that the molten material pushes itself into the spaces and crystallizes slowly below the Earth's surface. Now, because this cools very slowly, it allows the formation of larger crystals. And the examples of the types of rocks that you will get would be granite and granodiorite. On the other hand, when we're talking about extrusive igneous rocks, it's formed when the molten material erupts onto the Earth's surface and it cools very quickly. Now, because it cools very quickly, the crystals that are formed are very small. So they don't really have any crystals, so they kind of look like glass. The best way to explain extrusive rocks is to think of a volcano. Now, the rocks from the volcanic eruption are extruded, are pushed out of the Earth's surface. Now, the examples of these rocks would be basalt, pumice, and obsidian. To help me remember the difference between the 2 types of rocks, I have a little trick. Intrusive igneous rocks forms inside the Earth crust. Extrusive igneous rocks will exit the Earth's crust. Now, for this activity, you will need a tall container or a tall glass, about 5 tablespoons of baking soda, 400 milliliters of white vinegar, 10 milliliters of dish soap, 100 milliliters of cold water, and food coloring. You can try this experiment outside or somewhere without carpet, as it makes a mess. Combine the baking soda, dish soap, water, and food coloring in the container. Make sure to mix these all together with a spoon. Place the container in a safe location. Again, this will make a mess. Add the white vinegar to the container and watch the eruption. This experiment helps us to understand the process that forms the igneous extrusive rocks. Can you see the bubbles or the lava flow that you just created? Depending on the composition of the magma, as well as the amount of gas buildup in the volcano, you see some igneous extrusive rocks with a lot of little holes in them. This would be the gas escaping when the rock crystallizes very rapidly. Pumice is a great example of this. Let's now take a look to the sedimentary rocks. These rocks are formed by the accumulation and compression of sediments over a long period of time. The sediments can include small pieces of minerals, small pieces of plants, and other organic matter. The sediments move towards bodies of water like rivers, lakes, and ocean, and will accumulate at the bottom. Over long periods of time, this layer becomes a rock. Examples of these types of rocks would be mudstone, limestone, and sandstone. For this activity, you will need 3 to 4 different colored Play-Doh, small Lego characters or small pieces of dinos, trees, and even small pieces of branches from outside. Using the different colored Play-Doh, press each color into flat strips. Stack 2 strips together. Place the small Lego or branch, then stack the remaining layers. All these layers are now stacked one on top of another. These represent the different layers of sediments that have compressed together over long periods of time to form these sedimentary rocks. Now, can you see the piece of Lego or branch that you have placed in one of the layers? This represents a fossil. Fossils can also help us date how old the rock is, based on what type of fossil can be found in the different layers. Lastly, let's take a look at metamorphic rocks. There are rocks that have been changed or modified by heat, pressure, and chemical processes. There are always an undergoing change for metamorphic rocks. They are typically buried far below the Earth's surface. Examples of these rocks would be gneiss, marble, and schist. For this activity, you will need aluminum foil paper, pieces of wax crayons, all different colors, an oven, and oven mitts. Ask an adult for help and permission. Heat the oven at the lowest temperature setting, so approximately 70 degrees Celsius or 150 degrees Fahrenheit. You can also do this activity by using hot water in a container or a toaster oven. Do not put this in the microwave. Use caution with either method as it will get hot. Next, shape your aluminum foil into a cup. Using as many different colors as you like, cut the crayons into small pieces. Place the small pieces of crayons onto the piece of aluminum foil and place it in the oven. Keep an eye on the crayons and watch them melt. If you're using the hot water method, you will fill your container with hot water and float your piece of foil with the bits of crayons on top of the water until they melt all together. Once the pieces are melted, use the oven mitts to take the foil away from the heat and place it on a heat-proof surface to cool. When the melted crayons have cooled enough, are you able to see all the different colors that you used? At the beginning, you started with bits of crayons. These bits of crayons represent pieces of igneous, sedimentary, and even other metamorphic rocks. When we place these in the oven or over a heat source, they melt together and form a new multicolored crayon that represents our new metamorphic rock. Metamorphic rocks are rocks that have been changed through heat and pressure. Igneous, sedimentary, and metamorphic are three types of rocks that make up the rock cycle. The rock cycle allows us to understand the physical and chemical changes that can occur to form new rocks. Rocks are like books. You just need to learn the language and read the words in order to understand the story. By using the characteristics of rocks, you can find out how they were formed. So next time you go outside collecting rocks, use the handout to see if you can identify them. Thank you so much for joining me at home today. I had a great time teaching you about igneous, sedimentary, and metamorphic rocks. Have a great day.